Solving absolute value equations, example 4. In example 4, we have the quadratic equation and we have the absolute value of x squared plus 3x plus 1 must equal to 1, and we need to solve this equation. Now, with this equation, I am not going to find the restrictions because it's going to be too cumbersome. What I'm going to do is I'm going to immediately solve this equation. And then once I have the solutions, I'm going to test each of the solutions by substituting it into the left-hand side of my equation, which is the absolute value of x squared plus 3x plus 1. And if the solution gives me an answer of 1, which is on the right-hand side of my given equation, then I have a valid solution. So let's start. So with the first solution we have is going to be x squared plus 3x plus 1 equals to 1, or using the definition of an absolute value, I can say that x squared plus 3x plus 1 equals to negative 1. I'm going to solve x squared plus 3x plus 1 equals to 1. To do this, I want to write it into the standard form. So I'm going to transpose 1 across. So I have x squared plus 3x equals to 0. I see that x is the highest common factor. So I have x plus 3 times x equals to 0. So I have x equals to 0, or x equals to negative 3. My second solution will be x squared plus 3x plus 2 equals to 0 when I write it in the standard form. This is a quadratic that can be factorized. So I have the factors will be x plus 1, x plus 2 equals to 0. So I know that x equals to negative 1 or x equals to negative 2. So I have 4 solutions and I'm going to test each of these 4 solutions. Right, so my given absolute value equation was the absolute value of x squared plus 3x plus 1 was equal to 1. So I have a left-hand side and I have a right-hand side. I'm going to take each of the 4 solutions that I have calculated above and individually substitute them into the left-hand side of my equation. And if I get an answer of 1, which is the right-hand side of my equation, then I know I have a valid solution. So let's test x equals to 0. So if x equals to 0, my left-hand side will be 0 squared plus 3 times 0 plus 1, which is the absolute value of 1, which is 1. So x equals to 0 is a valid solution. Let's test x equals to negative 3. I then have that the absolute value of negative 3 squared plus 3 times negative 3 plus 1. This is going to give me the absolute value of 9 minus 9 plus 1, which is the absolute value of 1, which is 1, which is the right-hand side. So I have a valid solution when x equals to negative 3. I continue and I substitute x equals to negative 1. So if x equals to negative 1, in my left-hand side, I will have negative 1 squared, which is 1 minus 3 plus 1. This gives me the absolute value of negative 1. And the absolute value of negative 1 is 1. So x equals to negative 1 is a valid solution. Scrolling up, I see that the last solution must be tested is x equals to negative 2. So if x equals to negative 2, I'm going to have negative 2 squared plus 3 times negative 2 plus 1. This gives me 4 minus 6 plus 1, which is once again the absolute value of -1, which is once again 1. So all 4 solutions are valid. So therefore, my solutions are x equals to, let's just scroll up and have a look at my solutions. X equals to 0, x equals to -3, or x equals to -1, or x equals to -2. Looking at the graphical representation of this equation, we got the absolute value of x squared plus 3x plus 1. So the red graph is the graph of y equals to the absolute value of x squared plus 3x plus 1, which is the absolute value of a parabola. And the blue graph is the equation y equals to 1. And we see that the points of intersection of the two graphs are at x equals to -3, at x equals to -2, x equals to -1, and at x equals to 0.